Okay, most of the chemical reaction that you are already aware of is going to be redox reaction that involves the transfer of electrons from species to species. So we're going to discuss redox reactions in this part of your course, in this chapter 19. So it's mainly focused on electrons, study of the interconversion of the electrical into chemical energy, because when the electrons are transferred, they are actually in a relay of electrons, and the moving particle brings electricity to this energy being generated. So that we call electrical and chemical energy. So the chemical reactions involve electron transfer. We call them redox reaction. Reduction and oxidation processes happening at the same time. Okay, so what is happening? The electrons are transferred from one atom to another. Okay, so where the electrons are going to be transferred from, that is oxidation reaction happening there. And wherever the electron is going to, it's going to be the reduction reaction happening over there. So we'll try to figure out where the reduction is happening in the chemical reaction and where the oxidation process is happening in the chemical reaction. In short, the oxidation reduction reaction is called redox reaction. Electricity is the presence and the flow of electrical charge when moving there. When you have charged particles moving, the electricity will be generated, right? Those phenomena associated with the presence and the flow of electric charge, lighting, all these phenomena that you come across, these are all the examples of the flow of electric charge. So you can read about it at your own. Our purpose here to understand the oxidation reduction reactions in detail, and then the task and the learning goal of this part of your chapter is to be able to balance redox reactions. And you know that the redox reactions are special in a way that they must be charged as well as mass balance. Both need, there are two requirements for these reactions to be balanced. So we're talking about the oxidation is where the loss of electron is happening, and reduction is where the gain of electron is happening. You can say it in different terminologies, and it's very important for in terms of your multiple choice questions that you must know that whenever you say different things, you actually mean the same stuff. So you're saying loss of electron means the oxidation number of an element is increased. So it's the same thing. Or you can say a compound adds oxygen to it, or you can say a compound loses hydrogen. So all these things are going to give you that information that oxidation is happening here. So if you look at the oxidation, if you look at the oxidation number of an element which is decreasing, you are going to say that the reduction is happening at this atom, or you can say the gain of electron is happening. So you say gain of electron, you say the oxidation number of an element is decreasing, or a compound loses oxygen or a compound gains hydrogen. All these terminologies means you're talking about the reduction reaction. And as I've already told you, that the oxidation reductions are happening simultaneously. If the electrons are being lost, definitely they are being accepted by other species. So if one place is being lost and another place is being, so if you have two chemical reactants in a chemical reaction, one is losing electron, the other reactant is gaining electron, and they're going to go on the product side. That's what you can see, that where the oxidation is happening in the reactant and where the reduction is happening on the reactant. So I think skipping it, moving forward, one thing that you must understand here is what is an oxidizing agent and what is a reducing agent. We also call oxidizing agents are also called as oxidants, and the reducing agents are also called as reductants. So what does that mean by oxidizing agent? The species that removes electron, the species that is reduced, right? So the species that helps remove the electron, and the species, because it's helping removing, so it's being reduced by itself. So all oxidizing agents are being reduced and all reducing agents are being oxidized. Keep that in your mind. So let's go here. The oxidizing agent is reduced, the reducing agent itself is oxidized. So they both appear as reactants, okay? No products. We're not talking about the products. It's oxidizing agent and reducing agent, both are the chemical reactants in a chemical reaction in the overall redox reaction. So oxidation number is an oxidation state. It's a pseudo state that we give to the to the compound, to the atoms, to each element in the compound. Okay, it's a formal convention used as a bookkeeping matter for the flowing of electrons or to keep track of electrons during a redox reaction. Okay, and that helps us to determine what is being oxidized and what is being reduced. If we cannot keep track of what is going from where to where, we cannot actually determine which is being oxidized and which is being reduced. So for elements and monoatomic ions, oxidation numbers are just the charge of the species. Okay, so you have an element and a more elements. What do I mean by an element? A neutral atom is not charged at all. So if it's zero charge, overall charge on a neutral element, then it's going to be the zero oxidation state. And if you have a monoatomic ions like sodium ions, chloride ions, bromide ions, you have calcium ions, these are called monoatomic, or the atomic ions, they're going to go with their charge. So if like sodium is going to become sodium 1 plus, the oxidation, yeah, so this is what I'm trying to say. If you talk about the sodium, what is the charge? Oxidation numbers are just the charge of this. It goes for 1 plus, right? So the oxidation state is going to be plus 1. That is the difference between the ionic charge that we show is always going to be after the numeral. For the oxidation state, we put the sign first and then we show the numeral. So that's the difference between showing ionic state versus oxidation state. Right? So if I write sodium 1 plus, I'm trying to show its ionic state. When I write sodium plus 1, I'm talking about the oxidation state of sodium. It's plus 1 right now. So the same happens to all atomic ions. Make sure that you do not get confused with the polyatomic. We are not talking about the polyatomic. That's why it's very specifically saying here monatomic ions. So in molecules and polyatomic ions, now the oxidation numbers are not real charges. Okay. So what do we do? There are several rules that exist for assigning the oxidation number. So we'll go there and figure it out based on the rules. So you all need to memorize these rules while you're doing the oxidation number on these elements in a compound. So oxidation numbers are generally small whole numbers, but maybe fractional. We're not going to come across the fractional ones, but you must know that rarely they might be functional also, fractionals also. So there are rules that you're all going to memorize because it's going to become handy for you to determine the oxidation state of all the elements in a compound. The second thing that you must learn here is about the half reactions. Okay, so when we write a redox reaction, the oxidation reaction and the reduction reaction is just there. We need to separate it from the main equation, and we need to know this practice, and we must be good in doing that practice. So oxidation reduction reaction, we have to, and overall it is called redox reaction. We have to separate oxidation and reduction reaction from one equation that we call redox reaction. The example is right here. This is one equation that we may call it as a redox reaction, where copper is going to go into the, so this is the ionic state of copper, which is copper 2 plus. And from here on the reactant to, from reactant to product side, the copper is going to become an elemental form, solid. Okay, copper, neutral form. And here zinc is present on the reactant side as its neutral form. And that's going to go into the ionic form here. So now we have to see where the electrons are being lost and where the electrons are being gained in this chemical reaction. So if I look at the copper to copper, from copper 2 plus, because the elemental form of all these atoms, the oxidation state is 0. So what is happening? The oxidation state here is going to be plus 2, and oxidation here is 0. So from plus 2, it's going to go to the 0. So the oxidation number is reducing. Let's go back and see what is the definition. The oxidation number of an element decreases. From plus 2 to 0 means, it means 2 less electrons, right? And 0 means the copper is gaining 2 more electrons to become neutral, right? So it's actually what's going on copper. On copper, it is the gain of electron that is happening. So always remember this: oil, rig. Oxidation is the loss of electron. Reduction is the gain of electron. So on copper, reduction is happening. Why? Because the gain of electron is happening on copper. So gain means reduction is happening on copper. Okay. Now we're going to look at what is going on with zinc. So zinc from here to here, in its elemental form, the oxidation state of zinc is 0. From 0, you see that it's going to become 2 plus. So it means the oxidation number is increasing, which means oxidation. Or you can also look at it with this: oil oxidation is the loss. So here from 0 to 2 plus 2 means 2 less electrons. It's a loss of electrons. So on zinc, oxidation is happening. Why? Because I see the loss from reactant to product side, zinc is losing 2 electrons. So loss of electron means oxidation. So oxidation is happening on zinc. So zinc is a reducing agent because it is helping copper to be reduced, right? Because copper is reduced because the oxidation number is going down. Okay, it's decreasing. So copper is reduced. So what is going to be the reducing agent? Zinc is going to be the reducing agent where the oxidation is happening. And because zinc is being oxidized, so copper is going to be the oxidizing agent for zinc. Okay, so that is what you're supposed to learn here. Okay, now we can write down 2 half reactions. We can separate the oxidation reaction from the reduction reaction. I know that this is my reduction reaction and this is my oxidation reaction. So when I separate zinc, zinc initially was at its oxidation state of 0 because it's neutral. Okay, elemental form of zinc, solid. From here, it's losing 2 electrons. So when whatever is losing electron and we are writing that chemical reaction, loss means is going to be oxidation reaction, right? So in oxidation reaction, the lost electrons are, you're going to write it on the product side. When the electrons are being lost, we are going to show it on the product side. While in the second reaction, on the redox reaction here, copper is being reduced, reduction is happening. What do you see here? That copper from 2 plus, which is for 2 less electrons, it gained 2 electrons and it becomes neutral. It becomes neutral copper here. Okay, so when it's about the reduction, because it's the gain of electrons, we are going to show the electrons on the reactant side. You must pay attention to these little things because this is the foundation you're going to step on. Okay, and you're going to move forward. So the first step that you are learning here, if a chemical equation, if a redox equation is given to you, how you can split it into oxidation reaction and reduction reaction. Loss of electron, gain of electron. That's the terminology that you must know. Okay, so we'll do some practice on assigning the oxidation state to each element in these compounds. And this is how you will learn how, because this is what you have to do before you start balancing your chemical equation. In a chemical equation, you have to assign the oxidation state to all the elements present in a chemical reaction. So we are just trying to do a practice in this 19.1 example. That we can look at the compounds and we can do their oxidation states. Okay, so if we look at here, this is sodium sulfate. Sodium sulfite. Okay, so we're going to go by the rules. Okay, what we know in this compound is we know about the oxygen and we know about the sodium. Okay, oxygen is -2. Okay, and about the sodium, it says the sum of the oxidation state must be 0 for the neutral species. Okay, Um, a monoatomic ion is its ionic charge. So whatever the what is going to be the oxidation state for a monoatomic ion is going to be its ionic charge. We know that the sodium goes for 1+ in this compound, so it's going to be +1 oxidation state. But we're going to start from oxygen. So it's how many oxygens I have here? 3 oxygen. I know each is -2, so -2 times 3 is going to be -6 total oxidation number on the oxygens present in the compound. I know about the sodium. Each sodium ion is going to be 1+. I have 2. So 2 times 1+ means I have 3 pluses here. Sorry, it's going to be 2. It's going to be +2, right? It's going to be -2 for each oxygen. I was correct. -2 for each oxygen times 3. Just trying to make it a little clear. And that's going to be +3. Let me clear it for you. That's going to be, so 1 sodium is sodium 1+, right? So it's going to be +1 for oxidation state of each sodium. That's gonna be, sodium is gonna turn out to be +2 oxidation state, and the oxygen is gonna come out to be -6. And you know what it says here? The sum of the oxidation state must be 0 for the neutral species. We are now working on a neutral species. It's an ionic compound. You know the ionic compounds are neutral, right? So that means the sum of these charges should turn out to be 0. So we are done with the oxygens. We are done with the sodiums. What will be the oxidation state of sulfur in order to have it equal to 0? Definitely that's going to be +4. That's how we figured the oxidation state of sulfur in this compound, by having the fact through the rules about oxygen and the sodium. I hope you got it. Okay, so the next part is that we are going to look at an ion. It's a molecular ion, right? Polyatomic ion. And what it says about the polyatomic ion in the rules is that the sum of the oxidation state must be 0 for the neutral species, and it must be equal to the overall charge for the ionic species. We have these ionic species here. Sorry. Right? So the overall is going to be -2 at the end, right? So oxygen, I already know about the oxygen. 1 oxygen is -2, so 7 is going to be -14. Okay, so we got one thing done. Sorry. That should be, the result should be -2 oxidation state. Okay, the sum of the ionic species should be the charge of the ionic species, which is 2-. So that should be -2 oxidation state. So it means that we have 2 chromiums there. Each should be, we need 12 here, right? 12 means 2 times 6. 2 times +6 for each chromium. That will make it +12, and that will end up 1 - 2. So each chromium here is +6 oxidation state. We have 2 chromiums there, so that means 2 times 6 is going to be the 12. That is the number that we need here. 2 times +6. That's going to be +12, right? And then -14 is going to give us -2 at the end. So we know that chromium in this compound is in +6 oxidation state. For the tin bromide, it's again an ionic compound. For the tin bromide, you know the bromines, they are monatomic ions, -1 is going to be the oxidation state, because 1 minus is the charge on bromine. So each bromine is 1 minus. So the oxidation state for each, oops, not plus, it's going to be -1. Okay, that's the oxidation state on each bromine. So -1 times 4 is going to give me -4. And because it's a neutral species, so the sum is going to be equal to 0. So the tin is going to be +4. And the last one, the simplest one, we know about the sodium already. It's going to be the sodium. When it becomes an ion, it goes for 1 plus. So the oxidation for sodium is going to be +1. So that's +1. It means hydrogen is going to be -1 to make it equal to 0. So sum of these two is going to be equal to 0. So now what we have learned assigning the oxidation state to all the atoms present in a compound. That is very important when we'll jump on to, when we'll start working on balancing the redox reactions. Okay, so now we are going one further ahead, one step ahead, and we are trying to look at a chemical reaction, and we are going to assign the oxidation state to all of them in this chemical equation. So let's start with chlorine. And chlorine, diatomic chlorine means it's in its atomic state. So if there are 6 chlorine here, all of them are zeros. Okay, so 6 chlorines, but all of them have its oxidation state 0 in its elemental form. Iodine here is just 1 minus, so it's going to be -1 oxidation state for iodine. There's just 1 iodine here. For this water molecule, I know that oxygen is -2, so it's just 1 oxygen here. 3 hydrogen, we have 2 hydrogen, that is 3 oxygens, right? So 3 oxygen means -6. And we have 6 hydrogen, each is +1 oxidation state, because when hydrogen has this tendency to become both a positive ion and a negative ion, depending on to which atom it is going with. Here, when it goes with the metal, it was going to be a -1 oxidation state, because sodium is +1 oxidation state, which is a metal. Whenever hydrogen goes with the metal, that's going to go with the negative oxidation state. And when hydrogen is going with a non-metal, in this case, it's going to go for a positive oxidation state. It's written somewhere in the rules. Again, you can go and read it. Okay, so so now that is +1 is going to be +1, so times 3. Sorry, 3. Let's separate it from here. 3 times +1 is going to give it. Erase. This is a very space problem. So it's going to be 6 times 3 times. Sorry, actually, 3. Is this not working? 3 times. No, 3 times 2, 6. So that's going to be 6. Sorry. That's going to be +1 times 6. Or 6 times +1. I'm so dumb. Okay. So there are 6 hydrogen, each is +1. That's going to give me exactly +6 is here. So each hydrogen is +1 here, each oxygen is -2. That's how you're balancing it. Let's look at the chlorine, which is 1 chlorine is always 1 chlorine ion means 1 minus. So the oxidation is going to be -1. We have 6 here. -1 times 6, it means -6. So look at the chlorine from 0. This is -6, right? Now we're going to be looking at the iodine in this compound. So each oxygen is 2 minus, -2 oxidation state. So it's going to be times 3. and that should be equal to, which is -6, and the overall charge should be equal to this here, which is -1, right? And then it means this iodine is going to be +5 oxidation state. What happened to the iodine? Iodine was -1 initially, and it ended up on +5. Chlorines were 0, ended up on -6. Iodine was -1, ended up on +5. This is for the iodine, right? And your chlorine were all zeros, ended up on -6. Which means each chlorine is -1 oxidation state. This is exactly +6 oxidation state for hydrogen. So nothing happened for the hydrogen, actually +6 to +6, and oxygen here is -6 to -6. So nothing happened on oxygen, nothing happened on hydrogen. What happened? So we are looking at the reduction and oxidation. Again, do not forget that, right? So where is oxidation happening and where is reduction happening? That's our task here. We have to figure that out. So now if nothing is happening with the oxygen, with the water, hydrogen and oxygen, so I'm going to get rid of that. And eventually oxygen and hydrogen are not going to participate anyways in this chemical reaction. So just simplify it a little bit and leave the numbers for the species that we are now interested in. Right, so this is the iodine to this iodine here, which is this. What do you think? What happened on iodine? Iodine was -1, and it has lost actually 6 electrons. So it's going from -1 to +5. It is a loss of electron. Loss of electron means oxidation is the loss, right? It means on the iodine, it's oxidation happening there. Loss of electron. Oxidation is the loss of electron. Reduction is the gain of electron. So now what is happening on the chlorine? Chlorine was 0. From 0, the chlorine become -1. That means it's the gain of electron, right? So gain of electron is happening here. Why? Because the oxidation number is reducing. Gain of electron. So where is that? Yeah, from here, it's not, which is 0 for 1 actually, to -1 for each of them here. So we can write it down here in the next step. So that's how we have to figure it out, okay? But on the chemical equation, we have to figure out what we have to first assign the oxidation number to all the elements in all the compounds present, and then figure out where the electrons are being lost, where the electrons are being gained. And then we know that on iodine, here, that's going to go into iodine +5, which is the loss of electron, and chlorine from 0 is going to go into chlorine -1, which is the gain of electron, and the reduction is the gain of electron. This is how we have splitted the chemical reaction into oxidation reaction and into the reduction reaction. So I'm going to stop this video right here, and then I'm going to continue with another part. So I'm trying to make these some short videos, not too long for you guys, okay?